Okay, so here is the solution to that last question. So a pretty easy one. X to the power 3 minus 4x squared minus 11x plus 30 divided by x minus 5. Here's the full solution, so you can pause, check your work. But if you did it correctly, then you got a remainder of 0, which again, we will get into this more when we start talking about the factor theorem in lesson 3, I believe. Yeah, lesson 3. But because it has a remainder of 0, that tells us that f at 5 is equal to 0, which means that it is in fact an x-intercept, or x minus 5 is a factor. But we can also write the division statement as the original function is equal to the divisor multiplied by the quotient. Okay, and so that's just the solution for that one. Now, obviously it's not terribly painful, and honestly once you do it more and more, the long division of polynomials does become it becomes easier, but there is a trick, and so the trick is called synthetic division. And I think some of you may or may not have been exposed to this in 3U, but I will teach it as if you have not. And so to use synthetic division, you must, so there's a few rules. Similarly, the polynomial must be written in descending powers of the variables. If you're missing a power, you must fill in a 0 for its coefficient. Similar to long division, it is similar to long division, but you're adding rather than subtracting. And I'll show you what I mean by that. But that's like the one mistake that often gets made, is that they go through the steps, but then they end up subtracting instead of adding their lines. And then we write the coefficients only when we're doing the synthetic division. So we actually remove the variables from the question, and then we put the variables back in when we're done. And that actually makes it a lot easier, because then you don't have all these variables that you're dealing with, and the varying degrees of the variables. So, all right, so here I've already kind of started to set it up for you, but we have this question, 5w squared minus 4w minus 2 plus w cubed, divide that by w minus 1. And so check, is the divisor linear? And sorry, I should add that to one of our rules, but our divisor needs to be linear. Okay, so degree 1 divisor only is going to also be one of our rules. Is the divisor linear? Yes, it is. W minus 1 is linear. Is the polynomial written in descending order? No, it's not. So we need to rewrite this as w cubed, right, plus 5w squared minus 4w minus 2. Okay, now it's written in descending, and are all powers accounted for? 3, 2, 1, 0. Okay, so we're ready to set up synthetic division. So this is what it's going to look like. And these numbers here are the coefficients of the terms. So the coefficient here is that invisible 1 that we don't see, but let's put that in the green actually so we can see it. So this is where we get our 1, our positive 5, our negative 4, and our negative 2. Okay, so we write the coefficients 1, 5, negative 4, negative 2. On the outside, what we're dividing by is, again, we're looking for that corresponding 0 for the factor. So if we're dividing by the factor w minus 1, the number that goes here comes from doing w minus 1 equals 0, w equals positive 1. Okay, so if the factor is negative 1, we're going to put a positive 1 here. And we'll look at some examples where we might be putting even a fraction there or something. But we need to isolate w and use that number there as the number that's on the outside of our synthetic division. Okay, so the first rule is the first number always just gets pulled down. So this is always just going to be a 1, and that's how we start. Sorry, it's not always going to be a 1. It's a 1 right now because this is a 1, but this number will always get pulled down. So we've got this 1, and now what we're doing is we're doing 1 times 1. So we've pulled this number, we're multiplying these. So we're doing 1 times 1. And the product there, we're going to put underneath this 5. So 1 times 1 is 1. Now the difference, like I said, is we're adding our columns of numbers rather than subtracting, and so I put the addition sign there for us. So we're going to do 5 plus 1, which is 6, and then we're going to do the 6 times 1 again. Okay, so we're doing 6 times 1, and that number we're going to put here is 6. Negative 4 plus 6 is positive 2, and we're doing 2 times 1, which is 2. Negative 2 plus 2 is 0. Okay, so what have we just done here? That is synthetic division. This number at the end is always going to be the remainder. I think I have this written down below. Yeah, the last number is the remainder. And these numbers are the coefficients of the quotient. So if we had w cubed plus 5w squared minus 4w minus 2 divided by w minus 1, the answer would be w, and the the degree of the quotient will always be obviously 1 less than the original polynomial because we only divided out a linear or a degree 1. So if we divide a degree 1 out from a degree 3, then we're going to be left with a degree 3. We've only divided out one of those degrees. So let's write this as a division statement. So our original function was w cubed plus 5w squared minus 4w minus 2 is equal to what we divided out was the factor w minus 1, and what we're left with is w squared. Now that's a w squared because it's a 1w squared because this is a 1. Positive, because this is a positive, 6w positive 2 with a remainder of 0. We don't really need to write that, but if we want to put it there just so you can see where all the numbers go. Okay, so this is our original polynomial. This is the divisor. This is the quotient. This is the remainder. That's our division statement. And obviously that was a lot faster than had we have done long division. And if you are like weary or you don't trust it for sake of time, I'm not going to do it, but you could take this polynomial and use our long division, and you could divide it by w minus 1, and you will get back this as your quotient, w squared plus 6w plus 2. Okay, so again, we already put our division statement up there, so that's our answer. So synthetic division makes it much quicker to divide polynomials by binomials. So again, we have a divisor that is a degree 1, so that's good. We have a polynomial that's in descending order. We have 4, 3, but we're missing one of our values. So we need to rewrite this as 6w to the power 4. I don't like the looks of that 4 minus 3w cubed plus there's 0 w squareds. There are 2 w's minus 5. Okay, so this is where we're going to pull our coefficients from. We have a 6, a negative 3, a 0, a positive 2, and a negative 5. So I'm going to write 6, negative 3, 0, positive 2, negative 5. I'm going to set up my synthetic division. The number that goes over here would be the 0 that corresponds with the factor. So if we're dealing with the factor w plus 3, if we want to do it the long way, we can set it equal to 0 and know that we're dealing with a w value of negative 3. So I'm going to put negative 3 outside here, and then I can go through all the motions. So I'm going to pull that 6 down right off the hop. So I'm going to do 6 times negative 3, which is negative 18. And then I have to do my addition this time, okay? So I'm not subtracting, I'm adding these. So I have negative 3 plus negative 18. That gives me negative 21. Now I have negative 21 times negative 3. Okay, so negative 21 times negative 3, negative 63. Sorry, positive 63. Negative times a negative. And again, we're adding these. So I have 0 plus positive 63. So I've got a 63 here. Now I have 63 times 3. So 60 times 3 would be 180. 3 times 3 would be another 9. I've got a negative times a positive. So I've got negative 189. And again, I'm adding these. So 2 plus negative 189 is negative 187. And then I do have to do negative 187 times negative 3, which is going to give me positive. And I don't have to write the positive like I did here, but just to make sure we're keeping this straight, positive 561. And again, I'm adding these. Negative 5 plus 561 is positive 556. And so now this here does have a remainder. And what we would expect here is if we subbed in negative 3, okay, so let's call this function here p at x, our polynomial. And we now are pretty sure that p at negative 3 should equal 556. That's number one, and that's just a quick way you could check your work. If you put this function into Desmos graphing calculator and then you just ask it to tell you what is that function value at negative 3, you should get that answer. So there's one way you could do it, or you could just use your calculator. Obviously, you can just sub it into your calculator. And then we could write our division statement and say that 6w to the power 4 minus 3w cubed plus 2w minus 5 is equal to w plus 3. Now this is where you have to be careful when you're writing it out, your answer from synthetic division. So if we were dividing a degree 1, out of a degree 4 polynomial, then what we're left with is degree 3. So this is our degree 3, that coefficient. So we have 6w cubed minus 21w squared plus 63w minus 187, and then the remainder at the end plus 556. All right. One more example here, and I do want to look at this one because of the fraction, but I really, really do encourage you to play around with Desmos graphing calculator just for sake of time for this video. I'm not going to do it because just even having to type all this out. But if you put this function in there and you sub in that negative 3, you should get back your 556, which is the function value at negative 3, and it also just confirms that you've done your synthetic division properly. All right, so one last one, we will use synthetic division here, but this is one where, again, it's still linear, our divisor, but we really want to make sure that we're solving. So we have 2z plus 3. We have to figure out when we set up our synthetic division, what is the number that's going over here? Well, we would have to isolate z, so we subtract 3 on both sides. So we've got 2z is equal to negative 3, and then we divide by 2, and that makes z equal to negative 3 over 2. So negative 3 over 2 is actually the number that's going to go out here. And then again, we have to make sure we've accounted for the coefficient of all descending powers. So we would have a 6 for our degree 3. We would have a 13 for our degree 2. We'd have a 0 for our degree 1. And then we'd have that negative 9. And let's just put this so we know this is off to the side. Okay, so now we've got to figure out, okay, how many times does, actually no, first and foremost, we got to pull down our 6. 6. Okay, so now we're doing 6 times negative 3 over 2. We can do that off to the side. Let me just grab a different color here. So we have negative 3 over 2 times 6, we can divide out that. 6 divided by 2 is 3, and we end up with negative 9. Okay, so we've got 6 times negative 3 over 2 is negative 9. And now we're adding. 13 plus negative 9 is 13 minus 9, which is 4. And again, we have to do 4 times negative 3 over 2. So negative 3 over 2 times 4. Those can divide each other out and leave us with just a 2. So we've got negative 6. So we're going to put negative 6 in here. We're adding 0 plus 6 negatives, leaves us with 6 negatives. And then again, we have to multiply 6 times, now we're multiplying negative 6 times negative 3 over 2. So instead of negative 9, we're going to have positive 9. And again, we're adding negative 9 plus 9 brings us back up to 0. So that's great. So we have a remainder there. And so if we wanted to write this as a division statement, we could say therefore 6z cubed plus 13z squared minus 9 is equal to our divisor, which is 2z plus 3, multiplied by, and again the tricky part is pulling out the quotient from the synthetic division. This is the remainder 0. The original polynomial was degree 3, so our quotient is going to be 1 degree less because we only divided out a degree 1. So this is going to be 6z squared plus 4z minus 6, and then again we have that remainder of 0. We don't have to write it. And again, if you wanted to check your work, absolutely you could distribute this. 2z times 6z squared would be your 6z cubed, 2z times 4z, so on and so forth. You could go ahead and distribute this and it would simplify, or you could use a graphing calculator to confirm that this function is in fact the same as this function. Okay, that is all of the videos for this lesson. I know it was a bit of a long one, but these are tricky skills. Make sure you do the practice. You absolutely need just repetition when it comes to this long division and synthetic division.